In this video we will learn about magnetic field and some of their basic conceptual properties. As you can see here, a magnetic field describes the magnetic force that turns a compass to line up with the magnet. So essentially a magnetic field is a property that is created because of a magnet in a region around it, and that magnetic force is responsible for creating magnetic force, which can be experienced by magnetic materials. And magnetic field is present around every magnet and around every current carrying wire. And if a second magnet is brought in a space having magnetic field because of some first magnet, then the second magnet will feel something called a magnetic field. And then magnetic field is responsible for either pulling or pushing away the second magnet. And here now I define what are magnetic field lines. Field lines are defined as the direction that the north pole of a compass points when it is placed at that point. So essentially, to get the direction of a magnetic field in a space, you would take a compass and put at that point in space and then look at the direction pointed by the north pole of the compass, and the magnetic field line is pointing in the same direction as the north pole of the compass. Here, let's look at the field created by a compass, or the field created by a magnet. So here in this image we see a magnet whose north and south poles are shown, and then by using a small compass and by looking at the arrow which points its north pole, which shows the north pole of the compass, we see that the direction of the magnetic field can be obtained. So essentially, if small compasses are used to find the magnetic field around a magnet, the magnetic field will point in the direction shown in this image. So you can join these small compasses with the direction shown by this north pole, and that gives you the magnetic field line, and that is what is shown in the bottom. You can connect the small arrows shown by the compass and follow the direction of the north pole of the compass, and that gives you the magnetic field line. Two of the field lines are shown in this bottom image. So I want to differentiate here the meaning of magnetic field vectors and magnetic field lines. Magnetic field vectors are shown by arrows, and at any point in space you can obtain this magnetic field vector by drawing a tangent vector to the magnetic field line. So if you want to find the magnetic field vector at this point, you need to draw a tangent at that point. So magnetic field vectors are small vectors in space, whereas magnetic field lines occupy a region in space. Just like what we saw in the last slide, the magnetic field lines around a bar magnet, here we are seeing the magnetic field lines produced around a circular current loop. So the blue color is the loop that is carrying current in the direction shown by this arrow, and if you were to put compasses shown by these orange circles, you will see that the north pole of the compass will point in this direction shown by these circles. So this is the direction of the north pole of the compass. And then if you join all these, they're supposed to be vectors pointing in the direction shown by the arrow, and then you join these vectors, you will get magnetic field line. Also, in addition to circular current carrying coils, we can see that in the middle picture, if you have a wire that is carrying current straight up like that, shown by the blue color arrow, it also produces magnetic field around its surrounding. And by using compasses shown in the orange color, you can find out the magnetic field vectors, join them, and you'll get magnetic field lines. So magnetic field lines will be concentric circles for a straight current carrying wire. That is what is shown here. And when the wire is in the plane of a paper, then the field is perpendicular to the paper. What is important to note is that this current wire and this field are perpendicular to each other. You can clearly see that here. And at some later point we will see how we can use something called the right hand rule, shown by these arrows, using the right hand thumb rule, how we can figure out the direction of the magnetic field around a straight current carrying wire. An important point I want to point out here is that the direction, such as into the screen, and this direction is out of the screen, and this direction is into the screen. So you use dots and crosses to denote directions. So for the direction pointing inward, we will use cross, shown here, and for a direction pointing outward, we will use a dot, shown here. So these are the notations. Now let us discuss some properties of magnetic field lines. The first property is that the direction of the magnetic field is tangent to the field line, and the compass will always point towards the north. And if you want to find out the direction of a magnetic field vector using a compass, you just put a compass in a region of magnetic field, and the north pole of the compass gives you the direction of the magnetic field. The strength of the magnetic field is proportional to the closeness of the lines, that is, how dense these lines are. The density gives you the field strength of the magnetic field. And that density of lines is measured using a quantity called magnetic flux that we will see at some later videos. Another important point is magnetic field lines can never cross each other. So at no point in space you can have two directions for magnetic fields. That's what it means. And magnetic fields are continuous lines, and they form closed loops. They don't have any beginning or end. They go from north pole onto the south pole, forming circles. So these are some basic properties of magnetic field lines, and I think now we are ready to learn a little further about them in the next video.